Okay, so believe it or not, there's one more thing in this section that we have to discuss. And that is something called, this is a fun word, I should just make you guys try and pronounce it without saying it today. Eccentricity. Eccentricity. And the eccentricity of an ellipse defines how stretched out it is. Okay? And so if it has an eccentricity of 0, that means it's the same this way as it is this way, which means it would be a what? A cycle. And then if it has an eccentricity of 1, then that means it would be really stretched out. Okay? It says elongated ellipses have eccentricities close to 1. For example, the orbit of Halley's Comet has an eccentricity of about 0.97. Nearly circular ellipses have eccentricities close to 0. For instance, Halley's Comet. Oh, well, there you go. I'm sure you talked about its eccentricity in there. So the formula for the eccentricity is C over A. Pretty simple. So this is the focal length right here, right? That's the distance from the focus to the center. And A is half the length of the major axis. And then since we have that Pythagorean theorem thing, if you only know A and B, you can also figure it out using that whole formula right there, okay? So, Ryan, I might suggest you take a break from the scholarship thing and write down this formula real quick like. I don't think you're going to probably remember it. All right, so that's a fun little formula that you can use to figure out how elliptical your ellipse is. And the only other thing that you get to do that we didn't talk about yet, didn't have a chance to do yet, we did this with parabolas, is take the equation written out in the normal way and rewrite it in the ellipse way. Alright, so we're going to take x squared plus 4x plus 3y squared minus 5 equals 0. And we're going to show that it's an ellipse. We're going to figure out where the center is, the focus, its eccentricity, we're going to graph it, all those great things. Oh yeah. Yeah. Exciting stuff. Yeah. Okay, so here's how it goes. We're going to group the x's. We're going to group the y's. And we're going to take that number and put it on the other side. Okay? What goes in the spaces is I have to complete the square right here. So I'm going to take the 4 and cut it in half, which is 2, square, which is 4. So I'm going to go plus 4 right there, which means I have to go plus 4 over there. Yes? You got it out? Okay, so I left a space here just to trick you. I don't really need to complete the square here, right? Because it would just be plus 0. Yeah, because it's like, this is like 3y squared plus 0y, so I cut 0 in half, which is 0, and then I square, which is 0, so I add 0 to both sides, which doesn't change it, okay? So since this didn't have a regular old y term, I don't have to do anything with that. So now that I have this as a perfect square trinomial, I know that it factors into x plus 2 squared, very good. This is 3y squared and it's plus 0, so nobody cares. And then 5 plus 4 is, of course, 9. And then what did we say the deal is with ellipses? The equation always has to equal 1. How do I get this to equal 1? There he is. Divide everything by 9. I have to divide this by 9. I have to divide this by 9. And I have to divide this by 9. Okay? So that gives me x plus 2 squared over 9 plus, what does this reduce to? right? So it's going to be y squared over 3 equals 1. So now you can tell me all the things.
So A equals 9.
A does not equal 9. A squared equals 9. A equals 3. B equals square root of 3. And C equals A squared equals B squared plus C squared. So if you subtract the A squared and the B squared, 9 minus 3 is 6. Take the square root of that, C is the square root of 6. And then our new idea, the eccentricity, is C over A. So square root of 6 divided by 3. Can somebody give me that decimal on the calculator? Not yet, because he's going to die.
I just got it.
What? She's going to hurry and panic and screw it up. 0.81. Okay, so since 0.81 is pretty close to 1, that means this is a fairly stretched out ellipse. And so we can graph it just to see. Where's the center?
Is it
Negative 2, 0, because it's x plus 2, so the x coordinate is negative 2. It's y plus 0, so the y coordinate is 0. How far do I go to the left and the right? 3. 1, 2, 3. 1, 2, 3. How far up and down do I go? Root 3, which is like 1 point something. So I'll just go.
1.7.
Okay, so maybe there and there. Okay. Whoops, that's not a great ellipse, but so you can see it's pretty stretched out, right? Because the eccentricity is fairly close to 1. Okay? Got it? Pretty simple. All right.
What does the E do?
The E tells you, if E is 0, it's a circle. If E is 1, it's like crazy elongated, so it just kind of tells you. Okay.
On the x squared, the 4x is 1 3 y squared. How do you get that 4?
We took this number right here, cut it in half, 2,
Okay.
squared it, and got 4.
Okay.
Okay, so it's that completing the square thing that we worked on. We did it briefly with parabolas also.
So, divide by 2. Multiply by 2. No, square.
Cut it in half and square it, yeah.
When the district championship game is stronger.
Let's go. Whoa, whoa, whoa. Off gauge altogether, sorry.
Not forgiven.
Not forgiven. Dang it.
The dirt was so hard. Is your name?
Like, what?
How's your leg?
Everything. Fine.
This hard.
Is it pretty hot down there?
It was like 70, 75.
At least you guys don't have all black jerseys.